Welcome. Thanks for joining. Today we're going to rev up our racing engines and get rolling with machine learning using AWS Deep Racer, which is a really fun way to get introduced to the concepts of reinforcement learning. Now, you do not need prior machine learning experience and you do not need a physical race car to get started. Come as you are, and by the end of this session, we'll get you racing for prizes and glory. Hi, I'm Jenny Davies. I'm a Solutions Architect Manager in the Worldwide Public Sector team based out of Queensland, Australia. Let's have a look at the agenda for this session. We'll start by covering the broad view of machine learning services on AWS. We'll go under the hood of the Deep Racer car, learn about what makes it autonomous and how it's able to make decisions in real time. We'll introduce the concepts of reinforcement learning. Then, we're going to log in to the Deep Racer console with a demonstration of how you can get started. And of course, we'll talk about the Deep Racer League in 2021, how you can enter for lots of fun, learning, and chances to win prizes. Let's start with machine learning on AWS. At AWS, we like to define the machine learning stack in 3 layers, starting with the low-level infrastructure and working up to high-level abstraction services. The bottom layer is for the expert machine learning practitioner. This is where you're working directly with frameworks like TensorFlow, PyTorch, MXNet, and you're very comfortable building, training, and deploying your own machine learning models. We give you access to pre-built Amazon machine images with pre-installed tools, along with powerful GPUs and CPUs to help you get started quickly. At the middle layer, we find Amazon SageMaker, a machine learning service which removes the heavy lifting of machine learning for everyday developers and data scientists wanting to build, train, and deploy their machine learning models. In fact, SageMaker is an intrinsic component of Deep Racer. Deep Racer uses SageMaker under the covers to train its machine learning model. Finally, let's look at the top layer of the stack. And these are what we call our AI services. These services allow you to add intelligence to your applications through a simple API call. Some of these services feature pre-built machine learning models, ready to use. Others allow you to bring your own data to build a custom model and interact with that model via simple API calls. So when you think about building your skills or the machine learning skills of your team, where do you get started? Well, we know that developers learn best by getting hands-on. That's why AWS introduced tools like AWS Deep Lens to get hands-on with computer vision, AWS Deep Composer to get hands-on with generative AI, and what we're going to focus on today, AWS Deep Racer, to get hands-on with reinforcement learning in a fun, interactive environment. Back in 2018, Amazon SageMaker added support for reinforcement learning. And this enabled support for Deep Racer, which literally puts reinforcement learning in the hands of everyday developers. But remember, you can do this virtually. It isn't mandatory to have a physical car. And don't worry, we'll talk more about what reinforcement learning is soon. But first, what is Deep Racer? We have both physical and virtual race cars. This one is obviously a physical car and is the model called Deep Racer Evo. You can tell that because it's got 2 cameras at the front and a round LiDAR sensor on top. And yes, that tall end is the front of the car. Other than that, Evo is the same as the classic Deep Racer, which has a single camera. And you can see some specs for the car here on the side. But essentially, it's a 4-wheel drive chassis with an onboard computer running Ubuntu Linux. Once you've trained a machine learning model, you can race in a virtual simulator or download it to the onboard computer on a physical car so that the car can make decisions in real time. The Deep Racer Evo, as we talked about, has some extra features. These make it well suited to dealing with objects on the track or with other vehicles on the track, which are 2 new racing modes. So Even if you think you mastered the classic Deep Racer, Evo brings more capability to challenge you. If you did purchase the original Deep Racer, you can just buy an upgrade kit to convert it to an Evo. You don't need to buy a brand new car. If you don't have a physical car, no problem. You can race in our 3D simulator in the console. After all, we will train our models in a simulator, so why not race in a simulator too? Once you've built a model, you can race in the 2021 Deep Racer League. Or you can start a league of your own. We've got community racing tools allowing you to host your own competition and race against friends for fun. Now let's pause and talk about reinforcement learning. This is the type of machine learning that powers Deep Racer. In the broad context, artificial intelligence is where we teach machines to do things that usually require human intelligence, effectively getting machines to behave like a human would. Within this broad category, there's a major subset called machine learning. The idea of machine learning is we give the machine data and let it learn from that data. Capture those learnings in a model and then use that model to make decisions on new data. We can further break down machine learning into 3 categories. We've got supervised learning, where we provide the machine with previous data and the correct answer to learn a pattern from. Unsupervised learning, we just provide the raw data and let the machine find a pattern. And reinforcement learning, which is the coolest of them all. This is what powers Deep Racer. Essentially, what happens is you let an agent experiment with different actions in a simulation environment. It tries different behaviours, and you build a reward function which tells your agent when it's done something good or when it's done something bad by giving or holding back reward points. From those rewards, your agent builds knowledge which can be embedded in a machine learning model. This is the training process. Your agent starts by taking random actions. We call this experimenting. As training progresses, your agent will experiment less and use the knowledge it has learned more. We call that exploitation. Finally, that model can be used on its own. For us, this is the racing process and is purely exploiting learned knowledge embedded into that model. Reinforcement learning is not new. Do any of you have children or pets that you've provided rewards to incentivize the right behavior? Well, this is reinforcement learning. Say you've got a pet dog. If your dog does something great, you give it a reward, like a dog biscuit. If it does something bad, like make a mess, you don't give it a reward. We're incentivizing good behavior, and when you're successful, you've turned your regular dog into a circus dog. Now let's talk about some common reinforcement learning terms. We have the agent. The agent explores your environment and initially tries totally random actions. In the case of Deep Racer, our agent is a car, and in this session we will use those terms agent and car interchangeably. Then we have the environment which your agent interacts. In this case, our environment is a racetrack. The state. This is where your agent is within your environment. What state is your agent in? This is determined by inputs from the sensors on the vehicle. And when we are training in our virtual environment, we also have additional information available from the simulator, such as the coordinates of our vehicle. Action. This is the decision our agent takes. On a racetrack, this could be changing speed or changing the steering angle. When our agent is training, it will receive a reward based upon the action it takes. We will look at writing a reward function today using the Python language. our reward function says to our agent whether the action it took was a good one, more reward points, or a poor one, fewer reward points. Finally, an episode. Think of this as a bundle of collected knowledge. In our scenario, an episode ends when our agent completes a full lap of the track, or if our agent leaves the track. The Deep Racer service collects information from a whole bunch of episodes and passes that information to Amazon SageMaker to embed or train that knowledge into a machine learning model. To reiterate, the reward function is the most important thing for you to understand today. It is only relevant during the training process, and it gives your agent reward points based upon the actions your agent tries. And we will build a reward function today. We can have a look at a simple grid race to better understand this reward function. We want our agent to get to the finish line as fast as possible, so we will give large rewards for sticking to the center of the track. We don't want our car to use the top or bottom row of grid positions, so we're going to mark those as stop states. For the second and fourth row of grid squares, we'll still give a reward, but it will be quite small. They are valid states, but we don't really want our vehicle using that path. Here is what our reward values look like. After experimenting for a while, our agent will learn that staying on the center line will earn higher rewards than driving close to the sides. Let's see this in action. Our agent begins by experimenting wildly. It is going to end up in stop states quite a lot, and that is fine. It is learning. Over time, it learns how to get the most rewards and will explore less and exploit that learned knowledge, not just to get to the goal, but to get there with the highest possible rewards. Eventually, our agent builds enough knowledge that we converge on a steady state model, and we can use that model to get around the track in a really fast time. Now, have you noticed our reward graph on the left? Over time, our agent learns how to reach an end state while collecting more and more rewards along the way. That's perfect. That's what you'll look for in your reward functions when you write them. This means that during the training phase, your agent continued to learn better ways to interact with the racetrack for higher rewards and has embedded this knowledge in a machine learning model. Let's take a first-person look at what our agent sees. Early in the training process, our agent is mainly experimenting or exploring, so driving off the road is going to be very common. But later in the training process, our agent will explore less and exploit the knowledge in its model more. So we expect to be getting further and further around the track as training continues. Note, once training has finished, our model is ready for racing. When we are racing, there is no further learning occurring. Our model is being used by the agent to make every action decision, and there is no more random exploring. Let's go a little deeper into the training process. This training happens in a simulator with our agent, the car, capturing 15 pictures per second of what it sees from its camera or cameras. Each picture, along with any other sensor information, such as LiDAR, gives us the state of our agent. Now, the Deep Racer will take an action, either exploring randomly or exploiting existing knowledge. This action could be a change in speed or a change in steering angle. And now, the Deep Racer is in a new state. Based on telemetry made available from the simulator, we can decide how much reward we will give our agent, effectively telling it if it took a good action or not. And the more our car goes around the track, the more experience and knowledge it collects. After our agent has collected several episodes of knowledge, the information is passed to Amazon SageMaker to distill that knowledge into our machine learning model. And once that training is finished, we have a model which we can use for a virtual race or a physical race. We've talked a lot about this model, but what does this model look like? Well, in fact, it's called a neural network. The first layer, or the input layer, takes the pixels from our camera as well as LiDAR sensor information. In reality, our agent sees a grayscale version of this image, so it doesn't look exactly like this. This information goes through a convolutional neural network, or CNN. A CNN is a common architecture in machine learning to extract features from images. You can think of this CNN identifying features such as the curve of the track, where is the center line, and where the track boundary is. Once we have our features, we pass these into a second network called a policy network. Our policy network takes the feature information and decides on the action to take. Is our action to turn left, or right, or continue? What degree will the turn be, and how fast will the car run? We'll have a look at our action options in the coming demonstration. Next, we'll take a look at the AWS Deep Racer console. It's useful to know that AWS Deep Racer is an abstraction over several other AWS services. Under Deep Racer, we've got Amazon SageMaker. This is where our model training happens. We've got AWS RoboMaker, which hosts our simulated environment where our agent interacts with a racetrack to build knowledge. The knowledge our agent builds is passed to SageMaker via our S3 storage service, and this is also where our final model is stored. Deep Racer produces videos of the agent within the simulator, and these are made available via Amazon Kinesis video streams. Deep Racer also produces logs, which are stored in Amazon CloudWatch. The Deep Racer console provides a garage where you will build your virtual race car. You might want to build a traditional single-camera Deep Racer, or you may wish to use the Evo version with stereo vision and LiDAR. You're able to select your agent's action space. What actions is it allowed to take at each state? And we'll look a little closer at that in our demonstration. In the Deep Racer console, you get to program your reward function. We provide some examples. And you can syntax check your code before training. We're going to have a look at this also during our demo. When the car or agent is going around the racetrack, it will see images like this. But remember, it actually sees a grayscale version. It will see the track wall. It will see a field. If all four wheels of the car are on the field, it is considered off track, and that's the end of that episode. It sees the track surface. It sees the track boundaries. At this point, the car would be hugging the edge of the track and getting close to being off track. And our car also sees the track centerline. This is what the car sees. But during training, we've got a whole lot of telemetry that the simulator makes available to our reward function. That telemetry is what you use in your reward function to decide if the car is in a good state or a bad state during the training phase. Did it take a good action? Give it a good reward. Did it take a bad action? Don't give it a reward. Let's spend some time looking at the telemetry information that is made available during the training phase. So you can see we've got things like the heading, we've got the width of the track, we've got waypoints. But let's take a closer look. So XY coordinates. You can pull in the car's position on the track at each step. You can also pull in heading. Which direction is the car facing? You can pull in all the waypoints around the track. And you can also pull in the closest waypoints to the car's current position. Which is the next waypoint in front of it? And which waypoint is directly behind? You can make use of the parameter all wheels on track. Perhaps you want to reward the car for staying away from the edge of the track. Or, conversely, perhaps you want to reward it for hugging the edge. You can read in the width of the track in meters. And that is really useful in conjunction with other parameters like distance from center and is left of center. Perhaps you want to reward your car for sticking to the left or right of the track at particular sections of the track. You can pull in the current speed of your car. Perhaps you want to reward high speed on straight sections of the track. We'll dive straight into our demonstration now. Okay, let's head over to the Deep Racer console and get you racing. I like to start by going to the left-hand side and looking at the AWS virtual circuit. We can see which races are going on. At the moment, the Open Division is racing on the Po Chun Speedway. And we can also see where the Pro Division is racing. We're going to race in the Open Division, which is a time trial race. The first thing we do is go to the garage and set up a car. Click on Build New Vehicle. You can choose a single camera or stereo camera, and you can have a look to see the benefits of each. For time trial, I'm just going to use a single camera. You can also add a LiDAR sensor, which helps a lot with head-to-head or object avoidance racing, but isn't going to help much with time trial. And click Next. Our action space. These are the actions our agent or vehicle can take. Do we want to set a discrete set of steering angles? And here's where we set the granularity. Or do we want to let our agent steer in a continuous space, which is more complicated and will take longer to train? We'll leave this one at continuous. The speed. I'm going to leave the minimum speed at 0.5 meter per second, but increase the maximum speed to say 3 meters per second. And next. We'll give our car a name. I'm going to make my car red, so I'm going to call it Red Racer Summit 1. And choose a red trim. You can add tags if you want, and done. We've got a car. Great. It's called Red Racer Summit 1. Now go to Models, and we're going to create a model. Give our model a name. Since we're going to train on the Po Chun Speedway, I'm going to call this model Po Chun 1. You can add a description if you want. You can add tags. And importantly, choose the racetrack you wish to train on. We will train on the Po Chun Speedway. Scroll down and next. Race type. The Open Division is a time trial race, so that is how we will train. Training algorithm and hyperparameters. You can choose different algorithms and hyperparameters. I'm going to suggest that you leave this as is until you are very comfortable with your reward function. That is where you are going to get the biggest bang for your buck. Only come and play with these hyperparameters and different algorithms when you are very comfortable. Choose our agent, and next. Our reward function. AWS does provide some sample reward functions. The first is for following the center line, so the agent is rewarded more points for staying closer to the center of the track. There are other time trial reward functions, as well as a reward function for object avoidance and head-to-head. Take a look. We'll start with the follow the center line default. As you can see, we're pulling in the parameters using this params. And of those parameters, in this function, we are looking at track width and distance from center. We are using those two parameters to make an assessment as to whether we should give our agent high rewards or low rewards. The closer to the center of the track, the higher the rewards. If we're within 10%, we give a reward of 1. If you like, you can change those markers for what indicates close and far from centre. Perhaps you might want to give 2 points of reward for being within 10% of the centre. But what if you wanted to add some more interesting functionality? Let's say you wanted to pull in all the waypoints around the track. You could compare the coordinates of the waypoints to your current coordinates. Well, you'd need to pull in waypoints. And if you wanted to determine what is the waypoint directly in front and directly behind, those are available in the variable closest waypoints. If perhaps you wanted to pull in the coordinates of those waypoints, you'd look them up in the waypoints array. And here's some code to show you how to do that. Perhaps you wanted to look at the angle between your agent's current position and the next waypoint and compare that to your agent's current heading. Perhaps you want to pull in is left of centre and reward your agent for being left of the centre at particular locations on the track. Well, you'd pull in is left of centre. Imagine if we wanted to give double reward points for our agent being left of centre. Well, let's calculate reward as before, but at the end, if the agent is left of centre, we'll multiply that reward by 2. I'm happy with this reward function. Let's validate to make sure it's syntactically correct. Excellent. Now, how long should we train for? You can train for up to 1,440 minutes. I'll train this one for, let's say, 180 minutes. And at the end, sure, let's submit this model to the league and see if we can win some prizes. Click Create Model. And that's it. Your model is now training. You can have a look at your models. Let's take a look at one which is currently in training. And we can see this reward graph on the left-hand side. And we want to see this green line steadily rising. And that's what we see here. And as training continues, we'll get more and more reward points. Well, that's all there is to it. I wish you all the best with training your models. Now that we've seen the demonstration to get you started, we can discuss the 2021 Deep Racer League. There are 2 skill-based divisions. First, there is the Open Division, which anyone can enter to win digital rewards. If you finish in the top 10% of an Open Division event, then you move on to the Pro Division to race for physical merchandise. The top racers in the Pro Division go on to qualify for our AWS reInvent 2021 Championship Cup race. Also, watch out for special events during the year. For example, in 2020, we partnered with Formula One, giving competitors the chance to race against real Formula One drivers, such as Daniel Ricciardo. And don't forget, we've got tools for you to start your own community race. These can be great fun. Start a competition in your own company, race against friends, create tournaments. We've recently added new tools with enhanced features so you can run larger events. You can run major tournaments and even have seasons with championships in them. You can even broadcast your races to the world via Twitch. This is a fantastic way to have fun and build a community, perhaps within your own company. Why not race against the department next door? Here's some additional resources to help you, because once you start racing, you're not going to want to stop. You'll want to get better. You'll want to experiment and tweak your reward function. Start with the follow-on session from this one, which is a level 300 session where you'll use analysis tools to shift your racing into overdrive. Join the Deep Racer Slack community. Have a look at some of our workshops on GitHub. We've got courses, tips, and forums. Use the community around you to learn and get better. So, what are you waiting for? Race on over to the Deep Racer console, get on the track, and start racing for prizes and glory. I look forward to seeing you at the finish line. Now, you joined this summit to learn, and I encourage you to keep your learning going even after this summit finishes, with heaps of resources from AWS training and certification. We've got over 65 free digital machine learning courses available for you to learn and apply machine learning to your business. When you're ready, go and sit your AWS Certified Machine Learning Specialty exam to validate your skills and prove your credentials. For more information, head on over to the link at the bottom right of your screen and check out our ramp-up guide. Thank you so much for joining me. I wish you all the best with your machine learning journey on AWS. We do love to get your feedback. Please take the time to complete the session survey.